Good afternoon, everyone. Let's get started. Um, Today, we're going to talk about linked lists. Before we get started, uh, I want to make a small advertisement. AI Graduate School holds some events for undergraduate students and for both graduate students. And two of them might be of your interest. One of them is casual lunch. It happens March, May, September, and November, so 4 times a year. And you can talk about casual things with AI graduate school faculties. If you click this link, you could get more information. One is going to happen on this Friday. And there is another event called Open Lab. It's going to be on April 5th, 1:30 p.m. If you click this link, you can sign up for this event. And it is going to happen on at AI Studio. The building number is S7. You could talk about academical things with current master and PhD students. And you can also discuss some research projects going on and research opportunities like interns or graduate studies and etc. So basically, if you want to talk about AI things with current MS and PhD students, Open Lab might be a good opportunity for you. And if you talk with AI graduate school faculties, then casual lunch might be a good option. And even though casual lunch is termed as casual, you can think about serious things with AI graduate school faculties. So basically, if you want to talk to faculties, then go to casual lunch. And if you want to talk with MS or PhD students, then you might be interested in Open Lab. Okay, that was a short advertisement. And regarding course logistics, homework 3 is due on this Thursday, 1 p.m. Okay, before we go on, are there any questions?
오픈랩에 보면은 그 대상이 좋은 예정자라고 되어 있는데, 저거는 4학년을 할 수 있는 건가요?
Anyone can go to Open Lab because uh, you could talk about research opportunities like interns and graduate studies. Any undergraduate students are welcome.
음, 음.
Any other questions? That was a good one, though. Okay, let's move on. Before we talk about linked lists, we first need to talk about this PPP exercise where we left last time. Given an n by n matrix, the purpose of this problem is to return the elements of this matrix in this spiral order. So rather than the ordinary 1, 2, 3, 4, 5, 6, 7, 8, and 9 to 20, 12, we want to return items in this spiral order like 1, 2, 3, 4. So it is basically from left to right, and then from top to bottom, and right to left, and then bottom to top, and then left to right again. So basically, it repeats 1, 2, 3, 4. These 4 processes again and again until it reaches all the elements inside this matrix. Okay, let's implement this problem together first before we go into linked list. What we are going to do is because we need to return all elements of this input array to the matrix in the spiral order, we're going to make a list like this. And then what we're going to do is, as I told you, we're going to repeat the four processes. The first process was going from left to right, and the second process is going from top to bottom. The third one is right to left, and the fourth one is bottom to top. We're going to repeat these four processes, and we're going to repeat that process until as long as our array contains some elements. If our array becomes empty, then we should stop these four processes. Okay, so that's why we are checking whether our array contains some contains some items. All right, we're going to implement the first move. This move is from left to right. When you look at this matrix, it's quite easy to implement this first move because all we just need to do is get this first element of this matrix. This matrix or this 2D array or this 2D list contains another list of lists. And the first element is this list. And we just need to add this list to our result. That is going to be our first move. And how can we implement that? We're going to use this pop method, and we're going to pop the first list, this one, 1, 2, 3, 4. Then this implements our first move from left to right. Okay, that was our first move. And we need to implement the second move. This one is from top to bottom at the right end. What we need to do is, let's assume that we already finished the first move, and currently we have this matrix. And when we want to make the second move, we need to move from top to bottom at the right-hand side. And we need to add 4, 8, 12 in sequence to our result. And to do so, we also need to check whether our array is still containing some items. And for each row in array, so this row corresponds to this list, and then this list, and then this list. Therefore, this for loop is iterating through the inside lists, okay? And then what we need to do is just retrieve the last item. 4 first, and in the next iteration, 8, and in the next iteration, 12. And to implement that, we're going to append the last item from this row. This pop operation returns the last item of this list. Okay, so in the first move, we just retrieve the first list, and in the second move, we just retrieve the last items of each row like this. Okay, this was our second move. And we need to implement the third move. It is from right to left at the bottom. What we need to do is we went through this move. This was the first move. Second move was 4, 8, 12. And the third move is going from right to left like this. And this is somewhat tricky if you don't know this operation. I'm going to introduce a new operation. What we need to do is we first need to retrieve the last row because we need to move at the bottom. And we want to reverse the order of the items here. And we can implement this in two ways. The first one is you call this reverse method, then it will reverse the items inside. Or you can do another thing like array pop, and then Python offers this special operation. This will also reverses the items inside. And as you can see here, this operation and this operation do the same thing. Okay, that is the third move. And our last move, fourth move, is going to be from bottom to top at the left end. We also need to check whether our array is not empty. And how can we implement this? We are going to get the first items here, but in the reverse order. So rather than checking the first row, we want to check the last row first. And to do so, we are going to reverse the order of the array. And this will reverses the order of these 1D arrays. So when you call this first row will be returned, and then this one, and then the first row like this. And what we are going to do is we're going to pop the first item, 13, 7, and 1. Okay? And we're going to repeat this 4 moves until our array gets empty. And we're going to return result like this, okay? The indentation is somewhat weird here, but this is the result. Any questions regarding this problem? Okay, let's move on. Let's get down to our today's main topic, linked list. In the last class, we talked about arrays. Then why do we need a new list when we already have an array? Python lists are implemented as a dynamic array. We saw this. What I mean by dynamic is it changes the size of the list dynamically. It isn't optimal for all use cases. I told you that no one data structure can handle all situations. We need to have different types of data structures for different types of situations. Especially when you try to insert an item, then dynamic array is quite slow, especially near front of the list. And inserting too many elements can require recreating the entire list in memory. We also saw this in the last class. And then what is a linked list? A linked list is a chain of objects or nodes where each object holds a value and a reference to the next node. Therefore, here nodes contain two things. The first thing is a value, and the second thing is a reference to the next node. And the list ends when the final reference is empty. We do not know whether this node is empty or not, this node is the endpoint or not, but we can check it by seeing the final reference. If it is empty, then this is the final element. This is an illustration of a linked list. Here we have two things, data and a reference to the next item. And the last item contains no reference to the next one because this one is the final one. Here in this illustration, it is denoted as null, but in Python, we use none rather than null. Other languages use null, but Python uses none. And linked list ADT, or the functionality of a linked list, is like this. We first need to offer a constructor. Of course, we need to be able to create a list. And we should be able to get the size of the list. And we want to add some items at the front. This is prepend. And we want to remove the first item. and want to insert items after the specified node. And we have more ADT functionalities, but I'm going to discuss them in the implementation session. Okay, let's implement our linked list together and see what I mean by linked list. Okay. The basic idea is like this. We're going to implement a node class, and we need to be able to construct this node. And I told you that this contains two things. The first one is the item or the element, and the next one is a reference to the next node. And here we're going to refer it as next. We store element and store next as next. And I'm going to implement a stir method to support printing functionality. This. And after implementing this node, you can create linked lists. I'll show you some examples. Let's say our node contains apples, and the next node contains oranges. And here, we're putting A, this one, the first apple, as our next node. Then this means apples was at the front, but now oranges, the node containing oranges, is at the front. Strawberries, then A, yeah, like this. Then when we print A, this contains strawberries. So when we perform this, strawberry is at the front and orange next, an apple, and then none, like this. Okay. And when we print A dot next, then it's going to be oranges. A dot next, then it's going to be apples. So this is one way of implementing linked list. However, it's somewhat tricky to use this interface. So the last item is going to be none. And we can implement a display function. If A is not none, we're going to print A's element and then display A dot next. Then this function displays all the items inside this linked list, like this: strawberries, oranges, and apples. However, can you guys guess the problem with this implementation? Um, we implement this one as a recursion function. However, one problem is our linked list can contain like 1,000 elements or 10,000 elements. If that happens, this display function call will happen like 10,000 times. And I mentioned this in the recursion class that this could cause memory problem. And rather than using this recursive implementation, we should implement this one as iteration, like this. Okay, so these two functions do the same thing. However, the first one entails function calls, many function calls, and the second one does not entail function call. Okay, so this is one of the ways how we implement linked list, but this is not very convenient. We're going to upgrade our implementation in this class. But before we go on, I would like to give you PPP exercise, today's first PPP exercise. The first PPP exercise is like this. This one is creating linked list given a input list. So it receives a list of items we want to insert into our linked list. However, you need to be careful about the order. When we implemented linked list with this simple node, when we add new items, this new item goes at the front. So the last item into this list becomes the first item like this when we use this interface. However, in this problem, what we want to do is we want to put the first item of the list at the front. Okay? That is the difference between this implementation and this problem and this implementation. Okay? Take some time and try to solve this problem on your own. And before you tackle this problem, please send me a PPP message. I'll give it one more minute. Okay, thank you for sharing your answers. Let's solve this problem together. Um, I'm going to show you several solutions to this problem. The first one is scanning items from the back. What we are going to do is first create a none node like this. And for item in input list like this, we are going to scan the items from the back like this. And then we're going to use the same interface we used here, this one, adding new items at the front. Because we already reversed the order of the input list, we can just follow that interface. Node, item, and head like this. And we can just return head. All right? And the second solution is scan items from the start. The reason why I'm discussing this second solution is because in other languages, this reverse operation might not be supported. In that case, you need to use this second solution. That's why I'm discussing this second solution. We are going to initiate the head as none, as before. But what we are going to do is, for item in input list, if head is none, we are going to add a new item like this. Else, what we are going to do is, we move to the tail. Why do we need to do this? Because we first added this one, and this is already created as head. And when we try to add the second item, if you follow this operation, this will be added at the front. So the order might be 5, 4, 3, 2, 1 rather than 1, 2, 3, 4, 5. Therefore, after creating the head 1, we need to move to the tail and then add a new item there. Therefore, we first initiate our current node as head. And while current node.next exists, we're going to move to the end like this. And after that, to current node.next, we're going to create a new item like this. Then we can return head. This is our second solution. However, as you can see here, this is very inefficient because we need to move to the tail all the times. It's going to take O and square. And do we really need to move to tail every time we try to add new item? There is actually one way to solve this problem. We scan items from the start, but more efficiently handle this problem. How can you do that? Rather than just having head, we're going to have tail as well, like this. Um, for item in input list, if head is none, we're going to add new item like this. And when there is just one item, head and tail are going to be the same because we have only one node. And next time, what we want to do is we want to add a new item at the next position of the current tail. So this is creating a new node at the next position of the current tail. And because we have another item, we need to move tail to tail next. Then we're going to return head. So basically we have several solutions, solution one or solution two or three. And according to your situation, sometimes you might need to scan items from the start. And sometimes if this reverse operation is supported, then you can simply implement this function. Okay, so that was about creating linked list. However, this interface is not very usable. This is not very convenient. So what we are going to do is create a linked list class. Let's create linked list. We first need to support the initiator. This one receives a list of items. This is optional. If it is given, we need to initialize our linked list with these items, like the one we saw here, creating linked list. And what our linked list class is going to do is we're going to store a front node. And if items are given, we're going to add this item at the end. We are going to implement this append method soon. Okay, so that is our initializer. And because we defined our front node as semi-private attribute, we need to offer a method that returns this front node like this. You can also define this one as like self.head. In this case, we don't have to implement this front method. However, basically this one is more preferable to ensure encapsulation. And we can also check whether empty, our linked list empty or not by returning whether self is none or not. Okay. And we also need to have wrapper method. We already saw similar problem in the last class. So I'll just give you the definition of this wrapper method. Okay, this is our wrapper method. And we also have a prepend method. What we are going to do is, let's say we have a front and next item like this. And what this prepend does is add a new item at the front. So now this new element, given element, becomes the new front. And this is what we saw. We just update the front with this new node like this. Then this will prepend this new item at the front. However, this append method adds new item at the end. So in this case, this was the first configuration before this append. And after this append, this new item goes to the end like this. That is the difference between prepend and append. This is our second PPP exercise. Take some time and try to implement this append method. As usual, please send me a PPP message before you tackle this problem. I'll give it one more minute. Okay, thank you for sharing your answers. Let's solve this problem together. This one is somewhat similar to what we've solved in before. We first need to check whether our list is empty or not. If this is empty, then we need to create a new node at the front like this. Otherwise, we need to move to the tail and like this. And when we reach the end, we are going to create a new node there, like this. Okay. And as you can see here, this one is getting to the last element. And we can make it as another method like this. This. So we can change this part as self.list like this. And when we replace this part as this one, our code becomes more readable. We can understand, oh, this part is trying to get the last element of this linked list. Okay, so you can substitute this part as this last method like this. And we need to also support the len method. If self is empty, then we just return 0. Otherwise, we're going to move to the back and add count 1 by 1, like this, and then return count. This is going to be our len operation. Of course, you can make this one more simple by adding a self.count like this. And when we add new items here, you can increase like count 1 by 1 like this. And you just need to return self-count. This is another way of implementing this len function, len method. Okay, think about it. Still, our linked list class has some disadvantages. We are going to upgrade our implementation step by step. Okay. Our next method is removing the first element. How can you do this? At first, our configuration looks like this. We want to remove this first element. Then after removing this first element, the element at the next up front becomes the new front. So removing first element becomes very easy. We just update our front as the current front.next. Then this one becomes our next front. And by just removing the connection between this one and this one, then we can just remove the first element. We don't have to do anything else. Okay, that was our linked list. Um, However, I told you that our linked list is not perfect because we can travel only through one way, from front to back. However, sometimes you want to travel in the reversed order, like back to front. And to implement that, we're going to introduce a new concept. called doubly linked list. I'll show you the picture of doubly linked list. So this one is what a doubly linked list looks like. We have two connections. The first one is the reference to the front item, and the second one is reference to the next item. So this one indicates the next item, and this one indicates the previous item. By implementing this one, we can travel in both ways, backward and forward. Both are supported. And to support these two operations, we need to slightly modify our implementations. Our constructor received only next reference. However, here support the reverse order travel. So we need to also receive the previous reference like this. This is a simple modification. However, the ramification is pretty broad. And we can use the same stir as before. Like this. Okay, let's copy this one and modify this one as doubly linked list. What we are going to do is, rather than having just front, we are going to also store the rear. So this is the front, the very first item, and this is going to be the last item. Okay. Our front or first method remains the same. We just return the front node, and isEmpty is same as before. Wrapper might be somewhat different. But this is not of our interest at the moment. Then how should we change prepend and append? Let's think about it for a moment. I'll give you 1 minute. Just think about it. Okay, let's modify these two methods together. Prepend becomes somewhat complicated. Why is it so? Because we have new attribute rear, and we can't just simply prepend new item like this. We first need to check. Okay, let's just comment this and compare new implementation with the previous one. When self is empty, we are going to create a new node at the front like this. And our rear is going to be the self front. Because when we have just one item, the front and the rear item are going to be the same. And this is the tricky part. And the next step, when we have more than one, when we have at least one item inside this list, what we need to do is we first create a new node. And the next of this new node is going to be the current front. Okay. And the previous item of front is going to be this new node, right? And we need to update this front as this new node. So here you can see when you add new item element here, then this front becomes the second item. And this one's previous item becomes this new node. And this new node becomes new front. And the next item of this new node is previous self front. So if you think this one is somewhat complicated or you are puzzled, please draw this figure on your own and try to understand the relations between the previous front and the new front. Okay, let's modify this append together. If self is empty, what we are going to do is just call this prepend method. That will solve our problem. Okay, and what about the other cases? What we are going to do is create a new node like this. And this new node's previous element is going to be previous real element. So this was the real, and this new node becomes new last one. So this new node's previous one is previous self rear, like this. And self dot rear dot next is going to be our new node. And then last, we need to update the rear as new node like this. Okay. So when you draw this diagram, you'll be able to understand this relation. We haven't implemented many other functions, many other operations we need to support for linked list or double linked list, but you could think about them on your own. And when you draw these diagrams, then solving those problems will become easy. Okay, that was about doubly linked list. Are there any questions up to this point? All right, let's move on. You can also change this last method and this lem method. Think about it on your own, as well as this remove first. The last topic of today's lecture is Sentinel. Here, when we implement prepend and append, we need to think about whether the current linked list is empty or not. And this might look somewhat cumbersome in some cases. And what we are going to do is we're going to create Sentinel nodes. What are Sentinel nodes? These are dummy empty nodes and I'll just show you the implementation. So when we first implement our front and rear operations, we initialize them as none. However, what about just implementing them as node containing nothing, and rear node as node containing none, and the previous of this one is self.front, like this. And self.front.next becomes self-rear. And in the beginning, we already have two nodes, but those two nodes are meaningless. We don't care about them. And when we introduce these two dummy nodes, then our implementation becomes clear. What I mean by that is, we first need to change this isEmpty. We need to check because our front is no longer none. We need to check whether the self front.next is self rear. That means we have 0 items. That's how we check is empty. And to check the front item, we first need to check whether our linked list is empty or not. If that is the case, we're going to raise some error. Empty list error. We can implement this empty list error. And if our list is not empty, then what we need to do is return the next item of the front. So can you guys understand what this double linked list with sentinels are doing? So basically, what we are doing is originally, let's say we want to add 5, 3, 7, 9 to our list. Then what we did was create a non-front and non-rear node like this. And after that, we change this non and non as 5 and 5. They're indicating the same item. So front and rear. They indicate the same item. However, so this one is like this. And when we add a new item, then rear becomes 3, like this. However, when we introduce dummy sentinels, then front contains none, and rear contains none, like this. And between these rear and front, we're adding new items, like 5, 3, and 7. So the real first item is not front. However, the next item of the front. So that is what we are doing here. And by introducing these sentinel nodes, implementing last becomes also very simple. We need to check whether our list is empty or not. First, if that is not the case, what we are going to do is we just return the previous item of the rear node. Okay, that becomes very simple. And in the case of prepend, we don't have to care about this case. whether our list is empty or not. We don't have to think about it. What we just need to do is we just create new node like this. And the previous is going to be self front. And next is going to be self dot front dot next. And this one becomes self dot front dot next dot previous becomes new node because we have dummy front node. Okay, so here, let's say dummy front. So we need to move to self dummy front to next. And this one's previous one becomes new element. Okay. And then front dot next becomes new node. And because we have introduced dummy sentinel nodes, we don't have to think about exceptional cases. Our implementation becomes clearer. Okay. Are there any questions up to this point? Okay, that is linked list. I would like to give you some PPP exercises. You mean this one? Yeah, this one should be prev. Yeah, thanks for noticing. This one is actually prev and this one is next. Any other questions? Okay, let's move on. So this one is from Qualcomm's coding test. This one gives two linked lists. So the first linked list contains 4 and 7, and the second list contains 3, 4, 5. And this one represents 74. This one represents 500, 443, like this. And what we want to get is 617 as a list like this. And the second example is 36 plus 7. This is going to be 43, and you need to return 43 as this list. This is our first PPP exercise. And the second PPP exercise that I would like to give you is checking whether there is a circle in this linked list. I'm going to show you what a circle is like in linked list. So when you look at this, if you go to 5 and then when you call next, if it does not reach none, then we say this linked list is circular. And this is some examples of circular linked list. We just connect the last element to another list or some elements inside like this. I guess we are time is almost up. I'll give you just these two problems. And we'll start with these two problems in the next class. Okay, let's call it a day. If you have any questions, you can stay here. Otherwise, you can leave now. Thank you for your participation.